Hi, I'm iaso, and today I'm going to get to talk to you about one of my favorite things, Nix. Nix is many things, but my super hot take is that Nix is a better Docker image builder than Docker's image builder. As many of you know or have come to know, Nix is a tool that makes it easy to build packages based on descriptions using its little domain-specific language. For reasons which are an exercise to you, the listener, it is also called Nix. A Nix package can be just about anything, but usually you'll see it used to build custom software packages, your own Python tooling, an OS hard drive image, or Docker images. If you've never used it before, Nix is going to seem a little weird. It's going to feel like you're doing a lot of work up front, and at some level it is. When you're using Nix, you're actually doing a lot of the work up front that you would do in the future anyways. I'll get into more detail as this talk goes on. But who is this person, you might ask? I'm iaso. I am the senior techno-philosopher at fly.io, where I do developer relations. My friends and loved ones can attest that I have a slight tendency to blog a bit much, and I've been using Nix and NixOS across all my personal projects for like 4 years. I live in Ottawa over with my husband. It's all the morning, and I know we're waiting for that precious bean fluid to kick in. I got my Americano right there. Let's get the blood pumping with a little exercise. If you recognize my blog before, can you raise your hand? Oh, wow, that is way more than I thought. Okay. Raise your hand if you don't know what a Nix is. Okay. Raise your hand if you'd be willing to accuse yourself of being a NixOS or NixOS expert. Yeah, that's just about what I expected. And all right, you can lower your hands now. So, just to set expectations, this talk is a little bit more introductory than you might think. There's a mixed audience here. There's some hardcore users, there's some people who have never heard of this before, and there's a bunch of people in the middle. So I want this talk to be a bridge between the complete beginner and the super expert so that we can understand what Nix is, why you should care, and where it is needed the most. If you're like a super expert, just keep in mind that this is going to show you how bad the state of the world is and where our powers are needed the most. Today I'm going to cover what Nix is, why I think it's better than Docker for making Docker images, and some of the neat second-order properties of Nix that make it so much more efficient in the long run. So, I said that Nix is a package manager, right? Well, it's kind of a bit more. It's a package manager, a language, and an operating system, and it's kind of a weird balance because it was named by computer scientists, so they named it all Nix. But you can use this handy diagram inspired by the Holy Trinity to split the differences. You use Nix the language to make Nix the package manager build packages, but these packages can be anything from individual bits of software, configuration files, to NixOS images. Of course, this is compounded by the difficulty of adopting Nix at work if you have anything but a brand new startup or a home lab where you're willing to tear everything down and reinvent it from scratch. Nix is really different than what most developers expect, and it makes it difficult to cram it into your existing CI/CD pipeline. I really don't think that this is sustainable, and I'm afraid if there's not a bridge like this, Nix will wilt and die due to a lack of adoption in the industry. So I want to be that bridge today, and I want to show you to take advantage of Nix somewhere where it's desperately needed: Docker images. So to say that Docker 1 would be one of the understatements of all time. My career started just about the time that Docker left public beta and you had to recompile your kernel in order to use it. And Docker containerization has gone from super niche to so widespread that I'd say it's the de facto universal package format for the internet. Modern platforms like fly.io, Railway, or Render, they don't even bother doing anything but letting people run Docker images because it just works out better in the long run for everyone. And this gives people a lot of infrastructure superpowers. The advantages literally make the thing sell itself. It's popular for a reason. It solves real-world problems so elegantly compared to having to argue with your SRE or sysadmin team to get your packages updated in your local fork of Ubuntu because you want to use a library that's less than 2 years old. However, with Docker out of the box, there's just one fatal flaw. Docker builds are not deterministic, like not even slightly. Sure, if you go to the internet, you pull an average Docker file, you pull it, you build it, it'll probably work 99.99% of the time. That last 0.01% is where the real issues come into play. Speaking as a former wielder of the SRE shouting pager, that last 0.01 always comes into the factor at 4 a.m. Never while you're at work, always exactly at 4 a.m. Ask me how I know. One of the biggest problems that doesn't sound like a problem at first is the fact that Docker builds have access to the public internet. This is needed to download packages from the Ubuntu repositories, but it also means that when you're trying to go back and recreate an image at a later date, you can't just ask Ubuntu to roll back the repositories to what they were on that day. It's kind of annoying. And oh, remember, Ubuntu 18.04, it's going out of support this year. You're going to have a flag day finding out what depends on that version of Ubuntu with some CI pipeline breaks. Have fun. Even more fun, if you add packages to a Docker image the naive way, you get a lot of wasted space. If you run apt-get upgrade at the beginning of your Docker build, congratulations, you've just wasted several dozens of megabytes. Those extra files of the old versions will be shadow copies and wasted space, which will add up over time, especially with AWS and whatever, charging per millibyte of disk space and network access or whatever. So if fetching things from the internet is kind of hacky and all of this other stuff, what if we had the ability to just know what we needed ahead of time so we could already pull it, have it cached, and get it cached a lot more durably worldwide? What if your builds didn't need an internet connection because everything was already downloaded and in the path for you before your build even started? This is the real advantage of Nix when you compare it to Docker builds. Nix lets you know exactly what you're depending on ahead of time and then can break it into as few Docker layers as possible. This means that pushing updates to your program means that only the things that actually changed have changed. You don't need to upload the entire Python interpreter again. You don't need to wait for apt or yum or npm or did not finish to copy things just so that you can change a single line of code in your service. And this is why I think this is one of the best ways to adopt Nix is to use it to build Docker images. This helps you bridge the gap so you can experiment with the tools you want to use while still having the tools that you have to use, without breaking your existing workflows. Asterisk. As an example, let's say I have a Go program that gives you quotes from, I don't know, Douglas Adams. I want to deploy that program to a platform that only takes Docker images like fly.io, Railway, or Google Cloud Functions. In order to do this, I need to do a few things. First, I need to take the program and put it into a Nix package, and then, make sure that it works or whatever. And then I need to turn that into a Docker image, upload it into my local Docker daemon, yeet it into the cloud, and then deploy it and hope it doesn't break. Here's what the package definition looks like in my project NixFlake. Let's break this down into some parts. This project is a Go module, so I'm going to use the build Go module template. This will set up everything you need. It'll set up your Go compiler, it'll set up a C compiler for C dependencies, and if you use anything beyond the standard library, it'll take a hash of the vendor folder of your dependencies. The name of the package is Douglas Adams quote in kebab case. The kebab case isn't required, I just think it looked better. The version is automatically generated earlier in the file and out of scope of this screenshot. And the source code is in the current working directory. And because I don't need anything other than the standard library in Go, because HTTP is server and client is in the standard library, I can just pass null here. If you need external dependencies, you should probably use a tool like gomod to Nix. I linked it in the description at the end of the talk. Now that we have a package definition, you can build it with nix build.hashbin. That makes Nix build the bin package in your flake and put the result in /result. And as you see, you do nix build.hashbin, you run the command with --help. Let's pretend that actually tests the thing. And we look at it with file and see that it's an executable with some random garbage because that's how Nix makes things deterministic. So now that we have the package, we need to put it into a Docker image. And there's this neat family of helpers in the standard library called Docker tools. Docker tools is a bunch of wrappers that have different opinionated ways to put Nix packages into Docker images. There's two basic ways to use it. There's making a layered image and a non-layered image. A non-layered image is the simplest, easy way to do it. You basically take the program, all of its dependencies, any additional things like CA certificates, you put it in a folder in a single layer, and you push it up and pray. This does work, but it really doesn't let us take advantage of a lot of the unique properties of Nix. Making any change to a non-layered image means that you have to push all of the things that haven't changed. Nix knows what your dependencies are, so it should be able to take advantage of that when building a container image. Why should you have to upload new copies of glibc and Python over and over? It just doesn't make any sense. Nix also lets you make a layered image. A layered image puts every dependency into its own image layer so that you upload only the parts that have actually changed. Made an update to the WebP library to fix a trivial bounds checking vulnerability because nobody writes those in memory safe languages in Anno Dominium 2024? Yeah, the only thing that you need to update is the WebP library layer. It's great. The reason why this works is because there's a dirty hack at the core of Docker that nothing can take advantage of. Docker is actually a content-aware store, and the ordering of layers is added on in post. However, if you do this with the normal Docker build flow, you're never going to be able to take advantage of it because it just doesn't expose the right hooks to really use it. You know what does, though? Nix. A layered image means that every package is in its own layer, so glibc only needs to be uploaded once until we find yet another trivial memory safety vulnerability that's been ignored for my entire time on this planet, so that we need to have a fire day rebuilding everything to cope. That's the best part. So here's what a layered Docker image build for that Douglas Adams quote service would look like. Again, let's break it down. You start by saying you want to build a layered image by calling the dockertools.buildLayeredImage function with the image name and tag, just like you would with Docker build. Now comes the fun part, drawing the rest of the owl. Except it's just one line, because we tell Nix that we want the resulting command to be running the Douglas Adams quote server, and everything will just be copied over for you, glibc and whatever it needs. I think it needs libgcc now, all time zone data, all of that copied over for you. You don't have to think about it. It's great. And in theory, if you need to add the CA certificate root, because Nix doesn't ship it in Docker images by default, you just add it to the contents, and in this case, I say contents has the CA cert package. My website uses this extensively to copy things like Dino, Typest, and the doll tooling. So when you have this, you type in nix.build.hashdocker and whack the enter key, and a shiny new image will show up in /result. Load it using docker load angle./result, and it'll be ready for deployment. So if you've never seen this before, this is a really neat tool called Dive. It is an interactive Docker image explorer that allows you to see the different layers of an image. And in this example video, I'm going through and going down on the left to the layers, and you see how each individual package is its own layer. It's going to go backwards and unconstruct the image right here. And it's so great. If you've never used Dive before, I really suggest checking it out because it'll tell you how bad you are at making Docker images. And so that's it. We've done it. And all that's left is to deploy it to the cloud and find out if we just broke prod. But it should be fine, right? So the really cool part about the layered image flow is that it will work for cases where you have one repository with one service. But that content-aware hackery, it does not stop at just one service. If you have multiple services in the same repository, they'll share Docker layers between each other for free without any extra configuration. I don't think you can really dream about doing this with normal Docker without making a bunch of common base images and hackery and pain and suffering and goat sacrifices. And we're running out of goats. As a practical example, I have a repo that I call X. It's my experimental mono repo where I have like a decade's worth of side projects, tools, experiments, and other things that help me explore technology. It's also a monorepo for a bunch of my other projects. Yeah, this is a lot of stuff. I don't expect any of you to read that, so I made it small enough so that it goes below the threshold for 2015 vision, so that none of you can read it. Don't read it. And most of this is deployed across like 4 platforms, and I've been slowly converging on deploying everything to Docker images just to have some shred of sanity left. But because it's all in the same repo, it's all in the same flake, everything shares stuff, I push updates to Mimi, I push updates to ZDN. It's magic. It saved me so much time and upload speed, and it's just so great. Take that, managed NAT gateway egress fees. Oh, wait. Do you hear that? I hear it too. It's the pedantry alert. Yeah, in theory, you really can do the same flow with Docker. You have to put, like, installing packages in different layers, and you can do it, but the problem is, it makes your build steps look like this. Like, sure, you can do it, but you can also write memory safe C. And installing all your libraries in separate layers invokes the wrath of general protection fault, and that's not somebody you want to meet at 4 a.m. Not to mention, you have to turn the network stack back on during builds, which means, oh wait, now your images aren't reproducible. Oops. You'd have to rejigger search paths, CGO flags, compiler flags, and goat sacrifices again. It's just a mess. But compared to that, just look at this. This is building a Docker image in like 4 lines, and one of them is in like 4 lines and a closing curly brace. That's it. It takes care of the details for you, so you don't need to think about what's going on. You don't need to copy glibc yourself. It just does it for you. I love it so much. But that deterministic reproducibility thing I've been harping on, yeah, we're going hard into it now. Nix gives you the ability to time travel effectively and build software as it was a year ago. This lets you recreate a Docker image at a future date when facts and circumstances demand, because you had one on-prem customer that was allergic to upgrading and they ran into a weird issue and now you need to recreate production from a year ago. So, in theory, when you're writing package builds with Nix today, you're taking from the time that you would have spent to recreate it in the future. You don't just build your software, though. When you make a package with Nix and Flakes, you are crystallizing a point in time where the entire state of the software universe converges to get your result. It is beautiful. As a more practical example, I've been working on a project called ZDN for a few years. It's my content distribution network backend. The name is an exercise for the listener. Here's how easy it is to build a version from 14 months ago. One command. That is the entire command. I say I want to build something from the GitHub repository z/x at an arbitrary commit hash and get the ZDN Docker target with a URL fragment. And then I wait for that to run, and I load it into my Docker daemon, and I get the same bytes that I had in 2023. Go 1.19 and all. This party trick isn't as easy to pull off with vanilla Docker builds unless you pay a lot for storage, have repository mirrors, and, more goat sacrifices. But the even cooler part is that when I hit enter on that build command on my local machine, I didn't actually build a thing, because Nix has the idea of caching outputs of previous builds so that you don't have to do it again in the future. A Nix cache is effectively a safe place to put the output of builds so that the builds don't need to be done. If you're building something locally with Nix, that's because it could not find the thing in the cache so that it could be lazy and not have to do it. So there's a popular Ruby library called Nokogiri, and every time it bumps, everybody's developer laptops have to go into like Mach 7 jet fans building the horrible XML parser every time it gets bumped by like 0.1 femto versions. With Nix, in the development environments, it would already be built for you, so you don't have to have your MacBook even like get warm. It's so great. This is the way to really use the power of the cloud to your advantage. In my experimental monorepo, I use a service called Garnix to do CI for my stuff, and on every commit, it builds it, It pushes the built stuff to a cache, and then my laptop could just download it. It's beautiful. I just push button, receive commit status reports. It's super great because I don't have to think about it, and it was literally zero config in my case. I even have all my home lab machines rigged up so that they're built with Garnix, so that when I push a change to my configuration repo, every night at like 7, 8 p.m., I don't remember how it changes because it's midnight UTC and daylight savings just happened. They pull a new version of their config, they pull the stuff from Garnix, they update themselves, sometimes they reboot, and it's just great. I don't have to think about it. Everything comes back up, asterisk. Not to mention, I don't ever have to wait for my custom variant of Yosevka to build, because building fonts is apparently RAM expensive on the order of 20 gigabytes. Why? I don't know. In conclusion, though, Nix is a better Docker image builder than Docker's image builder. Nix makes you specify the results, not the process that you use to get there. Building Docker images with Nix makes it easy to adopt Nix if you already use Docker. Nix makes Docker images that share layers between parts of your monorepo. And Nix lets you avoid building code that was built in the past thanks to binary caches. And then in the end, you just get normal, ordinary container images that you can deploy anywhere, even big platforms like AWS, Google Cloud, or Fly.io. Before I get all this wrapped up, I want to thank everyone on this list for their input, feedback, and more to help make this talk shine. Thank you all so much. And thank you for watching. I've been iaso, and I'm going to linger around out in the foyer, or whatever the word is in French. And if you have any questions, I'll be there. But if I miss you, I email dockerimage@zserve.us. That pings my phone and gives me a notification that I can't ignore until I reply to the email. If you want to help work with me at Fly.io, my team is hiring. Ask me for details, and catch up with me if you want stickers. I have some extra info linked at the Q. What? Oh, did I forget to push it? Guess who forgot to press git push before this thing? I was busy setting up my own camera and stuff. I'll do it live. Let's do it live. Okay, I can't actually see this. Okay, so when I say I can't see this, I mean I literally can't see this. Git commit -sm YOLO. Git pull rebase, or git stash, git pull rebase. Okay, it should be up in like a minute. Yeah, I can take questions. The question was, is there a practical limit to the number of layers in a Docker image? Yes, and that limit is 128, and it's dictated by the file system drivers that Docker uses. However, if you get over that limit, Nix will just take the least popular dependencies and make them buddy-buddy together, and it'll just squish multiple packages into a single layer. Otherwise, it will just, it will have the most popular things be in their own layer, so you don't have to upload glibc 50 billion times. Probably 10, but I wasn't trying to optimize it. If I really tried to optimize it, I would have it use an embedded TZ data and build with cgo enabled equals 0, so you don't have glibc. But realistically, glibc is going to be shared between all your projects, so it's effectively zero cost at that point. And having a libc is more convenient than not having a libc, even though nobody can write C safely. Does the build process of the image require root permissions? I don't know what Nix requires. I think in theory you can do it with Nix rootlessly. You don't get the turning off the network stack side effect, but it would be able to mostly reproduce the thing. Yeah, I think it would work. Yes? If the Nix framework is installed as root, I believe if you're in the allowed users, it'll happen. If you're not in the allowed users, I don't know because I haven't actually used Nix in an environment where I'm not in the allowed users. You? Yeah, the question was, are you using Docker's image layer caching system and the ordering? The secret of Docker's image layer caching system is that the ordering is a lie that is just convenient to like do things. It doesn't actually need to exist that way. The layering is just a side effect of the implementation. The Nix works around it by creating the layers individually, and the ordering is really just arbitrary at some level. Yes? What is the minimum cache storage you need to build from 100 to 1,000 containers? I am not sure. I haven't built with that many zeros. I build 10 images, or 10 to 15 images most, and I don't have to pay for the storage, so I don't really think about it. You, back there. The question was what was the link between the cache and the determinism? Let me scroll back to one of my screenshots of my terminal here. I have a lot of slides. Okay, so you see this? You see that Nix store path next to interpreter there, where it's like /nix/store, and then a bunch of scary letters and numbers. Those scary letters and numbers are a hash of all of the inputs to the build, and that it forms the path for the output. It's not quite a content-aware store because it doesn't actually check what the bytes are because you can't really tell what the output is before you build it, and it will. Yeah, this is the inputs of all of that. Like, it assumes that things are deterministic, which they mostly are. There's some non-determinism that sneaks in because people embed the date that something was compiled, and as we all know, time is the ultimate in non-deterministic automata. But you can't link the wrong dynamic library, essentially. It's difficult to impossible, and this scheme does actually make your dynamic libraries effectively statically linked. Asterisk. Any more questions? That's it? Perfect. Thank you so much.